What is scoping and how does it apply to Solidity? Scoping refers to the availability of a variable within a function and a contract in Solidity. Solidity provides the following two locations where variables can be declared: contract-level global variables, also known as state variables, and function-level local variables. It is quite easy to understand function-level local variables. They are only available anywhere within a function and not outside. Contract-level global variables are variables that are available to all functions, including constructor, fallback, and modifiers within a contract. Contract-level global variables can have a visibility modifier attached to them. It is important to understand that state data can be viewed across the entire network, irrespective of the visibility modifier. The following state variables can only be modified using functions. Public. These state variables are accessible directly from external calls. A getter function is implicitly generated by the compiler to read the value of public state variables. Internal. These state variables are not accessible directly from external calls. They are accessible from functions within current contracts and child contracts deriving from it. Private. These state variables are not accessible directly from external calls. They are also not accessible from functions from child contracts. They are only accessible from functions within the current contract. If you don't know what a child contract is, we will talk about that when we work with inheritance. We have this base contract that has two variables, one uint public counter and another uint internal data. Let's just use these two and remember that internal is similar to private, being the difference that internal can be called by child contract, while private variables cannot be used in child contracts. In this function x, that is public, and returns a uint, we are modifying the public counter variable and assigning it the value 3. This is perfectly possible, and as I mentioned, it is the way to change state variables. It is through functions. Let's create another contract. In this caller contract, we create an instance of the base contract, and through the function getCounter, we will access the counter variable. This is perfectly possible because the counter variable is public. But as you already might know by now, we can't access the iData variable because it's internal. And because caller is not a child of the base contract, we can't access it. I changed the caller contract to inherit from base. Now let's see if we can access the variables. Let's compile. Now let's deploy the base contract. Now the caller contract, and down here inside the base contract we are changing the counter value to 3 via the x function. Now in the caller contract, because we are inheriting, we also have access to the x function, to the counter variable that is public, and through these functions we can get the counter value 10 and the iData value that is 30. Let's change it to private, recompile, and we already have an error and declared identifier. So the caller contract doesn't have access to this iData variable because it is private. So here we have this other contract that inherits from base and has this getResult function where we create two local variables and assign the sum of both a plus b to the iData variable, that is an internal variable from the base contract, and we return the iData variable. Now, inside the other contract we have access to the x function, to the counter, and to the getResult. As you can see here, we have the result of the getResult function. We are not getting the result here because the function is not set to view because we are changing the state, but we can define a view function to get the result. Now let's compile and deploy. We'll call getResult, and if we call the getIData, we get the 5 as expected. We didn't really talk about arrays yet, but if you Google it, you'll get. Array is a data structure which stores a fixed-site sequential collection of elements of the same type. So simply put, it's kind of a box where you put elements of the same type that start with index 0. In here we have an array of uint that is public and that 3 values. And below that we have a function, a next function, that is returning the array. Let's compile this. We already had the error. Okay, so what happens here is that Solidity can't give us the whole array. If you have a public state variable of array type, then you can only retrieve single elements via the generated getter function. This mechanism exists to avoid high guess costs when returning an entire array. This means that for huge arrays, this would imply really big costs for the transaction. So we can use arguments to specify which. So I'll change this and return the first element. Now let's compile and deploy. So here we have, using the public keyword generates this getter automatically for us. And if you can see, it also has this little box where we must type the index of the value in the array that we want to check. So we have 3 values. This is index 0, 1, and 2. Let's try with 1. So we get the uint to 5620. In the function x, as we might expect, we will get the 10 because the 0 refers to the first value of the array. Solidity provides access to a few global variables that are not declared within contracts, but are accessible from code within contracts. Contracts cannot access the ledger directly. A ledger is maintained by miners only. Solidity provides both block as well as transaction-related variables. Inside these global variables, we will add some examples. So here we have some block information. We can have the block base fee, we can have the blockchain current chain ID, we can have the block Coinbase that refers to the current block miner's address, the block difficulty, we will see this further down the course. We can have the gas limit, the number of the block, you can have the timestamp in seconds since Unix support. Other variables we can access are this message.sender, that is the sender of the message, the current call. We can have access to the message value and to the transaction gas price and to the transaction origin. This is different from the message sender. Again, this is something we will understand in the future. Make sure you like and subscribe so you can be notified when I upload the next video. Thanks for watching.